It is part 2 of section 2.5, logarithmic functions. In the first part, we studied inverse functions and exponential functions. The exponential function f of x equals a to the x is either increasing or decreasing. So it is one-to-one by the horizontal line test. Therefore, the exponential function should have its inverse. Here we'll define logarithmic functions. The logarithmic function with base a written in this form is the inverse of y equals a to the x. That means if we see this logarithmic equation, then you have to understand the equation in this way. A to the y equals x. Okay, let's see this example. Through the example, you may understand the logarithm more thoroughly. Find the inverse of y equals 2 to the x. And to find the inverse of the equation, the function, you have to solve the equation for x. That is the first step. And secondly, you can exchange x and y. And however, if you try to solve the equation for x, then impossible. So we may introduce notation log, and we can write in this way. Because it has its inverse, anyhow, we should be able to solve for x so that here we introduce a new notation and we write down in this way, and then now we exchange x and y. You may understand logarithm in this way, just a new notation for inverse of exponential function. The graph of y equals log base 2x must be the reflection of the graph of this exponential function about y equals x. As you can see in this figure, that is the given function and its inverse logarithmic function, and that is a reflection about y equals x. Okay, here we have a note. Equation 2.37, that one, represents the action of solving for x, and the domain of y equals logarithm ax must be range of y equals a to the x, which must be here 0 to infinity, the positive numbers. That means that logarithm accept only positive numbers. If x is 0 or negative, then it is not defined. Okay. Here, natural logarithm and common logarithm. The logarithm with base e is called the natural logarithm, and like that. And for log e x, we write down in this way, ln x. That means it's natural logarithm, so the nl must be the abbreviation. But in this case, here, maybe people can be confused, so that as in log, start with L, so it's a change the order, so the ln is used for natural logarithm. Once the base is 10, then it's called the common logarithm, and we here discard the base 10. But once you see this one in mathematical formula, then you have to understand that as this common logarithm. Now, but when you are using here calculator, then that is exactly following the notation. ln means a natural logarithm, log means a logarithm base 10. Once you are using calculator, then the same way it is following. However, when you are using the computer program and using some computational languaging, then function ln is usually can be called by using log, and for common logarithm you have to use log 10. So be careful. Log means natural logarithm and log 10 means the common logarithm. Okay. Here we have properties of logarithms: product rule, quotient rule, power rule, and reciprocal rule. And I believe you learned this one from high school, and so that just read once and you can memorize here these rules. Inverse properties. Okay, here a, so it is exponential, and log a and logarithm, so then a and log a can be cancelled to become x, and also the same here log a and a exponential cancelled because they are inverse each other, so that becomes x. Once a is chosen to be e, special case, we can write in this way. Also the same, if a is e, then we have here ln e to the x equals x. Okay. Now let's solve these equations. Okay, let's try to solve one of them. Here, part B. Okay, from this one, by using the product rule, we can write this left-hand side. That is now log base of 3 and x, and here x minus 2, which is now same as 1. But now that one is also can be changed into like a log and base 3 and 3. And so that this portion is the same as that. So here we can get from this one, and x minus 2 is same as 3. Or by using this portion, okay, by using this portion and by using the definition, this equation is the same as, okay, there's a base of 3. So you have to understand this one in this way. 3 to the 1, that is y, equal, that is x, and x minus 2. By using definition, you can reach that one. Or by changing 1, it's the same as log base 3 and 3. You can reach that one. Either way, you can get the same result. Okay, so from here now, we have to solve the equation. That is x squared minus 2x and minus 3. Move this to left-hand side. We have that. There's a x-axis separation, and 1/3 separation is a minus and plus. That means x must be minus 1 and 3. Okay, we reached this one. However, logarithm admits only positive numbers, so that here x cannot be 0 or negative, so that this minus 1 cannot be solution. And here if you think 3, then here you can easily see that well defined both them, and then this becomes 1, that becomes log 3 1, which is 0, so that left hand side, right hand side the same. Okay. We have a claim here. Every exponential function with some various bases. It's a power of the natural exponential function. Here, that is a to the x. From this one, for example, intermediate term will become here now by using base e and then logarithm, natural logarithm, and a to the x. Now, by using power rule, x can go out here, so we can reach out over there. And this can be written as in this way. Now, e to the x and power logarithm of a, right? So that every exponential function like a to the x is a power of the natural exponential function, right? Okay. Yeah, every logarithmic function is a constant multiple of the natural logarithm. Okay, log ax, base a, can be written in this way, and natural logarithm of x over natural logarithm of a. This formula is called the changeable base formula. It can be proved quite easily. We start with natural logarithm of x. That can be written in this way. Now x itself is the same as now that one, a to the log ax, and now, okay, that portion is power, so the power can go out by using the power rule, so we can reach it over there. Now, for log ax is natural logarithm of x divided by this quantity, so we can reach out this formula. Okay. So here, based on claim 2.49, all exponential and logarithmic functions can be evaluated by the natural exponential function and the natural logarithmic function. And they are here in MathTalent, EXP, and LOG functions. Okay. And this is end of the section and end of the chapter. You will work on a project called Kenny edge detection algorithm for color images while you are studying the next chapter. Next chapter is about the programming with calculus. So you learn this one, and now before finishing this one, you will finish a project. Okay, thank you.